The workshop in Kovrov smelled of cutting oil and metal shavings. On the workbench, partly assembled, lay what would become the DP-27, though in early 1927 it existed as components awaiting proof of concept. Vasily Degtyaryov moved between the bench and his drawings, checking tolerances with calipers that had measured hundreds of iterations before this one. The barrel assembly rested on wooden blocks, its gas port positioned precisely 415 millimeters from the chamber face. Too close, and excessive pressure would cycle the action violently, battering components and reducing service life. Too far, and insufficient gas would fail to operate the mechanism reliably. Degtyaryov had calculated the position based on pressure curves and piston stroke requirements, but calculation meant nothing until metal proved the mathematics. Above the receiver, the pan magazine mount drew attention immediately. Circular, flat, designed to accept a magazine holding 47 rounds in a spiral arrangement, it violated the aesthetic of every machine gun Degtyaryov had studied. The Maxim, the Lewis, the Hotchkiss, all proclaimed their purpose through belts, or vertical magazines, or water jackets. This weapon looked incomplete, as if awaiting attachment of some larger system. But that apparent incompleteness was the point. Degtyaryov had stripped away every component that required a second person. No belt to guide, no water to replenish, no tripod to adjust. A single infantryman could pick up this weapon, load a magazine, deploy the bipod, and begin sustained fire. The question was whether sustained fire would remain sustained long enough to matter. The gas system represented months of refinement. Long-stroke piston operation was well understood, but understanding didn't guarantee execution. The piston had to travel far enough to ensure complete bolt rotation and extraction, yet remain short enough to keep the overall length practical. The return spring had to balance cycling speed against recoil management. Too light, and the cyclic rate would climb beyond controllable limits. Too heavy, and the weapon would fail to cycle in cold conditions or with degraded ammunition. Degtyaryov picked up the bolt assembly. The locking lugs engaged the receiver through a simple rotation. A quarter turn locked, another quarter unlocked. Simplicity in locking meant simplicity in manufacturing, and simple manufacturing meant the weapon could be produced in quantities that doctrine demanded. The Soviet military didn't need perfect equipment, it needed sufficient tools delivered in time to matter. If stories like this help you see how engineering quietly shaped history, tell us in the comments what surprised you so far, and stay with us for the next chapter. 3 months earlier, Degtyaryov had sat across from military procurement officials who presented requirements that bordered on contradiction, light enough for one person to carry alongside personal equipment, powerful enough to deliver suppressive fire at ranges exceeding 300 meters, reliable enough to function in conditions ranging from Arctic cold to Central Asian dust, simple enough to manufacture without specialized tooling, and all of this chambered in 7.62 Kes-54 Memoir, a cartridge designed for bolt-action rifles, not automatic equipment. The challenge wasn't creating a light machine gun. Other nations had accomplished that. The challenge was creating one within Soviet industrial capabilities while meeting Soviet operational requirements. Western designs assumed manufacturing precision that Soviet factories couldn't guarantee. They assumed maintenance infrastructure that Soviet logistics couldn't provide. They assumed operating conditions that Soviet geography made impossible to predict. Degtyaryov had approached the problem by inverting it. Instead of asking how to make a perfect design, he asked what imperfections could be tolerated. Could the equipment function with slightly looser tolerances? Yes, if the gas system was forgiving. Could it operate without a quick-change barrel? Yes, if engagements remained short enough to prevent critical heat accumulation. Could it feed from a limited-capacity magazine? Yes, if infantry tactics emphasized movement and maneuver over sustained suppression. Each compromise opened a new design space. Loose tolerances meant simpler machining. Fixed barrels meant fewer precision joints. Limited magazines meant no belt feed mechanism. Stack these compromises, and mass became negotiable. The equipment that emerged weighed 8 kilograms because Degtyaryov had systematically questioned every gram. The bipod design alone took 24 iterations. Mount it too far back, and muzzle rise during fire would lift the barrel off target. Mount it too far forward, and the operator couldn't control recoil effectively. The final position, near the muzzle, created a balance point that kept the equipment steady while allowing rapid traverse. The legs locked with simple spring catches, no adjustment mechanism, no complexity, nothing to break or require maintenance. Degtyaryov understood that design was constrained optimization. Every feature served multiple functions, and every function imposed trade-offs. The buttstock shape positioned the shooter's eye at the correct height for the sights, while providing a stable cheek weld. The pistol grip angle allowed control during recoil, while keeping the trigger mechanism simple. The receiver dimensions accommodated the bolt carrier's stroke, while maintaining structural rigidity. But all of this engineering meant nothing if the fundamental feed system failed. And the pan magazine, that distinctive circular profile, remained the design's greatest uncertainty. The mechanism's logic followed principles established decades earlier, but implementation required precision in execution. When the trigger released the firing pin, it struck the primer with sufficient force to ignite the propellant. As pressure built in the chamber, the projectile accelerated down the barrel, while gas bled through the port into the cylinder beneath. This gas, still expanding at high pressure, drove the piston rearward. The piston connected rigidly to the bolt carrier, translating gas pressure into mechanical motion. As the carrier moved backward, cam surfaces machined into its body engaged corresponding surfaces on the bolt. These cams forced the bolt to rotate, disengaging the locking lugs from the receiver. With the bolt unlocked, the entire assembly continued rearward. The extractor, a spring-loaded claw fitted into the bolt face, pulled the spent case from the chamber. An ejector, positioned in the receiver, struck the case at precisely the right moment, throwing it clear of the equipment. The return spring, compressed during this rearward motion, stored energy for the forward cycle. At the rearward limit of travel, spring force reversed the carrier's direction. Moving forward, the bolt face contacted a fresh cartridge held at the top of the magazine feed position. The carrier's momentum drove the cartridge forward into the chamber. As the bolt reached battery, the cam surfaces reversed their action, rotating the bolt and engaging the locking lugs. The firing pin, held under spring tension, remained cocked until the trigger released it for the next cycle. This sequence repeated 500 times per minute, the DP-27's cyclic rate. Neither exceptionally fast nor notably slow, this rate balanced controllability against suppressive effect. Higher rates consumed ammunition rapidly and generated heat that degraded accuracy. Lower rates reduced the equipment's effectiveness in the suppressive role. The gas system's adjustment mechanism allowed regulation of piston travel. In pristine conditions with quality ammunition, the regulator could be closed partially, reducing the amount of gas entering the cylinder. In adverse conditions, cold temperatures fouled components, degraded ammunition. Opening the regulator increased gas flow, ensuring positive cycling. This adjustability meant the equipment could function across the environmental extremes Soviet forces would encounter. Barrel heating imposed operational limits. After approximately 150 rounds of continuous fire, the barrel temperature approached levels that affected accuracy and, if sustained, could cause metallurgical changes that weakened the steel. Degtyaryov designed the barrel for removal without tools once a locking collar loosened, allowing replacement in field conditions. But the fixed barrel design meant infantry squads couldn't maintain truly continuous fire the way belt-fed, water-cooled equipment could. Do you think this design choice was inevitable or a risky gamble at the time? Share your view in the comments and pass this story to someone who enjoys understanding how things really work. The first firing tests revealed what drawings couldn't predict. The gas port position proved correct. The equipment cycled reliably with standard ammunition. But the magazine feed presented immediate problems. Rounds occasionally failed to feed smoothly, the bolt face riding over the cartridge instead of chambering it properly. Degtyaryov examined the feed mechanism closely. The pan magazine held cartridges in a spiral arrangement, with a spring-driven rotor advancing them toward the feed position. The geometry was complex. Each cartridge had to rotate from its position in the spiral to align with the chamber axis. The tolerant stack-up of magazine manufacturing, receiver dimensions, and bolt-face geometry created occasional misalignment. The solution required redesigning the feed lips and adjusting the magazine rotor spring tension. Stronger spring pressure ensured positive feeding, but excessive force would burden the bolt carrier during cycling, potentially causing failures when the return spring couldn't overcome feeding resistance. Degtyaryov settled on a middle position, sufficient tension to maintain feed reliability while remaining within the carrier's force capacity. Extraction problems surfaced with prolonged firing. As the chamber heated, cases expanded and gripped the chamber walls more tightly. The extractor, dimensioned for normal temperature extraction, occasionally tore through the case rim rather than pulling the case free. Degtyaryov increased the extractor hook depth and modified its heat treatment to provide greater tensile strength. These changes eliminated extraction failures in subsequent testing. The bipod mounting required reinforcement. Initial designs allowed excessive flex during fire, causing the equipment to bounce and disrupting accuracy. Strengthening the mount and repositioning it slightly forward improved stability without significantly increasing weight. The adjustment represented a classic engineering trade-off, adding material in one location to improve performance while removing it elsewhere to maintain overall mass targets. Trigger mechanism refinement consumed weeks. The sear engagement had to be crisp enough for controlled single shots, yet reliable enough for automatic fire. Too much engagement, and the trigger pull became heavy and inconsistent. Too little, and the equipment risked accidental discharge or runaway firing. The final design balanced these requirements through careful geometry and spring selection. Sight alignment verification showed acceptable accuracy at 300 meters, the equipment's effective range. Beyond this distance, the combination of cartridge ballistics and barrel length made precise fire impractical. But within 300 meters, properly trained operators could deliver effective fire, and effective fire at that range satisfied the tactical requirement. The pan magazine's true significance became apparent not during firing tests, but during operational simulations. When personnel practiced deploying the equipment from march to firing position, the magazine's design advantages emerged clearly. A belt-fed design required at least 2 people for practical operation, one to fire, another to manage the belt and prevent jams. Even designs that theoretically allowed single-operator use functioned poorly without assistance. The belt had to be protected from debris, kept untangled, and guided into the feed mechanism smoothly. In dynamic situations, these requirements created constant problems. The DP-27's pan magazine eliminated this dependency entirely. A soldier carried the equipment and several loaded magazines. Reaching a firing position, he deployed the bipod, mounted a magazine, charged the equipment, and began firing. No coordination required, no assistant needed, no external ammunition management. The 47-round capacity meant frequent reloading, every 8 to 10 seconds of continuous fire. But reloading was a simple matter of removing the empty pan and mounting a fresh one. This independence transformed infantry squad organization. Previously, machine gun teams operated as specialized elements, often attached to rifle squads rather than integrated into them. The DP-27 allowed organic integration. Each squad could include a light gunner who moved with the squad, deployed when needed, and required no special support. This organizational change rippled through Soviet infantry doctrine. The magazine's circular form served practical purposes beyond feeding. Lying flat atop the receiver, it presented minimal profile when the operator was prone. The pan's diameter allowed reasonable capacity without excessive depth that would interfere with sighting or handling, and the design distributed ammunition weight evenly around the receiver's center, maintaining balance during fire. But Degtyaryov knew the magazine also represented a vulnerability. The pan extended above the equipment's profile, creating a target that could be damaged by impact or debris. The spiral feed mechanism inside contained delicate springs and followers that required protection from dirt and moisture. Operators would need to treat magazines with care, a requirement that field conditions often made difficult. The alternative, belt feed, would have increased the equipment's capability in sustained fire scenarios. But it would have required a second person, added mechanism complexity, increased weight, and demanded ammunition handling infrastructure that Soviet logistics couldn't guarantee. Degtyaryov chose independence over endurance, mobility over sustained suppression. This choice defined the equipment's character. The DP-27 wasn't designed to replace heavy machine guns. It was designed to give infantry squads organic firepower they could deploy independently, rapidly, and without specialized support. The Pan magazine made this possible. The DP-27 entered service in 1927 and remained in frontline use for nearly 2 decades. Production exceeded 800,000 units, equipping Soviet infantry through intense periods that tested every aspect of the design. The equipment functioned in temperatures that froze lubricants solid and in dust that choked mechanisms designed with tighter tolerances. The gas system's forgiving nature proved crucial. Personnel could adjust the regulator to compensate for varying conditions, maintaining reliable cycling when other equipment failed. The simple bolt design meant field maintenance required minimal tools and training. Components could be replaced by unit technicians rather than requiring factory service. The Pan magazine's limitations became apparent in prolonged engagements. 47 rounds disappeared quickly, and reloading under pressure created vulnerable moments. Personnel learned to time reloads during lulls and to position spare magazines for rapid access. These tactical adaptations compensated for the magazine's restricted capacity. Manufacturing efficiency justified the design compromises. Factories produced DP-27s in quantities that equipped entire divisions, and production continued even as industrial capacity faced severe challenges. The equipment's tolerance for manufacturing variation meant that units built in different facilities or time periods maintained compatibility. Parts could be salvaged and swapped without precision fitting. Later designs attempted to address the DP-27's limitations while preserving its strengths. The DPM modification introduced a pistol grip and repositioned the return spring to reduce sensitivity to barrel heat. The RP-46 added belt feed capability while maintaining magazine compatibility. These evolutions acknowledged that the original design had achieved its core objectives, even as circumstances revealed areas for improvement. What Degtyaryov created wasn't a perfect design. No such thing exists. He created a tool that balanced competing requirements within specific constraints. The DP-27 gave Soviet infantry mobile, organic firepower when they needed it, using industrial capabilities available at the time in a form that personnel could actually employ effectively. The distinctive Pan magazine, visible in historical photographs and instantly recognizable, represented more than a feeding mechanism. It embodied a design philosophy that prioritized independence and simplicity over theoretical maximum capability. In this prioritization, Degtyaryov demonstrated engineering wisdom, understanding that the best solution isn't always the most sophisticated one, but the one that actually works in the conditions where it must function. The DP-27's legacy persists in design principles rather than direct descendants. Modern light machine guns employ different technologies and feed systems, but they serve the same fundamental purpose, giving small units organic firepower without requiring dedicated teams. The questions Degtyaryov answered in 1927 remain relevant. How much capability is sufficient? How much complexity is acceptable? And which compromises serve the mission better than theoretical perfection? If you enjoy calm, true stories about how engineering shaped the world, subscribe to the channel, leave a like, and tell us from which country you're watching.